everybody. Thanks for having me. It's good. It's always exciting when you see the thing you're about to talk about being demoed live on stage just before you get on stage. So thankfully, the MCP server still works, so that was good. My name is Martin Woodward. I work at GitHub, and we're going to talk about our MCP server at GitHub. But actually, what I'm going to be talking about mostly is the MCP protocol and how you can get involved in the MCP community. We'll not be touching that much on the GitHub MCP server at all. It's mostly about the MCP protocol. Hopefully that's good. So, as you might have heard of GitHub. It's the home for the world's developers. But we've created GitHub Copilot in June 2021. And that kind of changed how we think and how a lot of people work with developer tools. It was a very exciting project to be on. I was lucky to be involved in the first version and have been involved ever since. As we've been doing that project, we've been learning a lot along the way. We've got now over 15 million users. We started by just doing autocomplete. So just, because LLMs weren't that good yet. So we did autocomplete because it was only a little bit of code that needed correcting. And then as LLMs got better, we went into chat. And now we're at where we are in 2025, where the LLMs have got so good and can run longer times unsupervised that we're able to move to the world of the software engineering agent, which is where the industry is this year and where we've seen explosive growth across LLM usage for development. But you need to get data, you need to do all that sort of thing, and that's kind of where MCP has come into place, to be able to do things with your agent and be able to get data into your agent, as we just saw. But what I thought would be useful, first of all, would be to kind of, with all these agents together and interoperating, how did we get here? How did we get to where we are today? So it's amazing to me. I'm old, very old now, and it's interesting to be here at the beginning of yet another epoch, yet another change of the way that we build things. So as I say, Copilot introduced in June 2021. We only got function calling in GPT in June 2023. So that's less than, just over 2 years ago as we sit here in the room. So this is very, very fast. We then rapidly followed that with Copilot extensions. And that was basically a way for end users to be able to plug in to that whole function calling thing and developers to be able to provide tools to Copilot specifically to be able to then talk to the rest of your development system. We're GitHub. We know that while we're at the center of your developer universe, you need to be able to talk to everything. Otherwise, there's no point having it there. So that's why we introduced extensions. Then later that year, Anthropic announced MCP. And the cool thing about MCP was that the tool discovery is more dynamic. You can tell the LLM what tools you have available, and you can give the LLM sufficient context for it to be able to do the tool calling, rather than the function calling, which is a lot more kind of API-based. We've got full support of MCP inside of Visual Studio Code, and then in April of this year, this year's been fat. It's been a long year already. So April, we did the local MCP server for GitHub, the official one. When Anthropic launched, they did a version of an MCP server that used our APIs, and then we worked with Anthropic, and we have our own, and made it open source, and everything's good. And then we also have now a remote MCP server. So if you don't want to install anything, as you saw in the demo from a colleague at Docker, you can just talk to a remote MCP server, and everything works. So that's kind of the history, and it's moved very, very fast. But it's important to know that you're all here at the beginning of this new wave. And so things you might think, how does this work yet? It's because it's so early is why, a lot of times. As we've been building MCPs, we've learned a few lessons. The first lesson that we've learned, actually, is that everybody knows MCPs for tools. It's what made MCPs successful and why people start using MCPs. It allows you to do things like create issues, send email, execute scripts, perform actions, as well as allow you to get data to add to the context of your prompt for your LLM. So that's the key values. Tools is at the center. But it's much more than just tool calling. If you just call tools, then you miss out on some of the other parts of the MCP protocol that allow you to call tools better, more efficiently. I did an update on the MCP protocol. These are the basic constructs in MCP. So we obviously have tools at the center on the server, but what you can do as a client, you can ask for resources from the server. So, if you're talking to GitHub, that's things like files, issues, like data that you need to be able to be part of your context. Or if you're talking to Notion, that's your Notion forms. If you're talking to a database, that might be database schema, that sort of thing. So the resources, you can separately access them as a client of an MCP server. We also have prompts, which is cool. Prompts are a bit like the stored procedures of the MCP world. You can ask an MCP server, hey, what good prompts do you have? And there's variable substitution in there that you can insert data. So if, can I have a prompt to do this thing, please? Can I have a prompt to do that? You can actually ask the server for some good prompts, and the LLM can do that, and it'll be great. Over on the client, the client can also provide a couple of things. One is sampling. So a client can allow the MCP server to send back, be able to do a lookup against the LLM that the client is using. So at GitHub, in GitHub Copilot, we allow the developer to pick whatever model that they want from whatever development environment they're in. And so it's essential for an MCP server like ours to be able to use what the customer wants their LLM to be. So if you want to use Claude Sonnet 4, great, we can do that. And now our MCP server can go to the client and say, hey, use the user's chosen LLM to do this bit of work for me. Or if you want to use Gemini, or if you want to use whatever models. So that's why that exists. And then finally, routes is the ability to the client to specify where in the file system, where in the client server resources live, and where the server can access. So you don't go accessing for things that you might need root level permissions, for example, to be able to see, or you stay within your sandbox. And then dynamic discovery, is part of the MCP protocol that people know. It discovers tools. Lastly is actually elicitation. That's very underused, as you'll see. But that allows the MCP server to tell the client, hey, I need more information about X. I need to make a decision. Can you ask a question? Do I do A or B? That usually means that goes to the client as a question. Do you want me to do A or B? Or it might be the LLM makes that decision for you, but you're asking the client for input at this point. And that helps prevent hallucinations. That helps prevent ungrounded work. If we look at the tools, it's great. And the reason why MCP was super successful is because it is such a pragmatic way of calling tools. But the problem that we have today is a lot of our examples with MCPs are just focused on the tools rather than the bits around the tools. And so unless we as a community do more work to get better at tool calling, nobody's going to be aware of what else is possible, which is one of the reasons I'm here, to try and help you see what else is possible and help you dig in, encourage you to dig in. I did a quick survey of all of the MCP clients on Monday. And of those clients, there's about 80 today, different client implementations of MCP. 79 of them know about tools. But if we look here, only 3 of them know about elicitation part of the protocol or have it implemented. So it's very, very early in terms of our implementation of the spec. The spec was only written in June, so it's nobody's fault, but it's still early days. If you are experimenting and want to, you're building an MCP server and you want to test out everything, Actually, I would encourage, I'm not on the VS Code team, so they're a sort of sister team to my team at GitHub. But I would encourage you to give VS Code a try. It's the only client that's the end client that implements everything in the MCP protocol and all the authentication specs. So try it there, and then that'll help you hopefully plug it in everywhere else. Right, so the first lesson that we learned once we started adding lots of tools is that actually tools are not the answer. Just like humans, the more choice you give to your LLM, the more likely it is to get confused. And the same is true with tools to LLMs. LangChain did some great research around the degradation in terms of performance of the LLM for coding, the more tools that it had access to. So you get overloaded, it can break down, and it can slow down the performance as well. Therefore, what we did initially, I have a very, very easy job because you are my end users, you're developers, you're technical. So it's easy for me to do things because I can ultimately just give you control, and you can decide which tools to switch on and off, and you like that as developers. Many people who are not building developer tools don't have that luxury, because if I went to a normal person when they were booking a flight or trying to do some insurance comparisons, for agent-to-agent protocols, and asked them to pick tools, they would, no, they're not going to, normal people don't want to do that. Developers like to do that. So we initially gave you all of the control in the client to be able to control which tools that you select, but what we obviously need to do is dynamic tool discovery. That's what's great about the MCP protocol, in that you can query the server to say which tools are available. But what's been added in the June version of the protocol is actually the ability for the server to say, okay, we've been having this conversation. I'm now going to add a new tool to you, LLM, that you can call, that it kind of unlocked at this point in the conversation. And it can broadcast the fact to the calling client that this tool is now available. And then it can broadcast this fact that this tool has gone away to the LLM as well. And by doing that, it reduces the amount of tools available to the calling model at any one time to, again, minimize the amount of tools to increase the accuracy, to prevent confusion. So that's what dynamic discovery is good for. The next lesson that we learned, unfortunately, is installing MCPs is a pain. Nobody wants to do it. Trying to do cross-platform MCP installation is an absolute nightmare. Now, Docker we're just on. Docker is fantastic as a developer for getting a containerized MCP server, but that's fine for us as developers. That isn't going to work for end users, for normal people. So containerization is great, but only gets you so far. And if you look at the amount of commands you can use when you're defining your MCP server, there's everything here. Trying to get it to run on Linux, on Mac, on Windows, basically impossible to do reliably as a local MCP. Now, the other lesson that we learned, I did a quick grep of the logs for people calling our endpoints from MCP servers. Nobody upgrades a working local MCP installation ever. Once it works, I am not touching it until it stops working. Now, this protocol is changing so fast, our world is changing so fast, that's not sustainable for us, you know what I mean? If people are never going to upgrade. And because of the way that we do installation, like trying to do auto upgrade is basically impossible. So local, again, is great for development, is not going to work at scale once we start rolling these out to normal people. So remote MCP servers have been introduced, and this was kind of in the protocol from the very early days. MCP has always been a network protocol. And a remote MCP server is obviously installed remotely. It doesn't have any access to the client, like file system and things, without asking the client, and it's very easy to upgrade to scale. So as a service provider, remote MCP is great, and as an end user, it's fantastic too. But as a developer, there are some downsides, If I'm building an MCP server and I have to stand up a remote server first, it's hard. So local MCP has some great advantages to you as a developer when you're building MCP servers for speed of iteration and for experimentation. The critical thing that you need with remote MCP servers, we mentioned there, is good authentication, but we're going to touch on that in a second. Locally, you can rely on local secrets and the permissions of the local user. The trick that we did is we built both a local MCP server, and then we used that exact same logic hosted to be our remote MCP server. So our local server, fully open source, everybody can develop on it, anybody can add features, it's all good. We can, as an internal team, iterate very quickly, and then we can take that logic, host it remotely, and then we upgrade our remote server as well. And that then enables server-to-server scenarios. So you can go to github.com, talk to the GitHub MCP server, and manage that whole thing because there's a remote instance, rather than having to rely on your local instance. The next lesson that we then had, once we did remote MCP servers, is password or PAT-based authentication is bad. It's an anti-pattern. You can very easily, managing those secrets is hard. They always become long-lived secrets, which is bad for security. Preventing them from being accessed by other MCP servers that have access to the file system is very, very complicated. There are lots of reasons why password-based PAT authentication is bad, which is why in June we actually added OAuth support to the MCP protocol. So now MCP supports proper tokenized security with short-lived tokens. It supports OICD Connect as well. So OAuth support is key, but not every client SDK has OAuth support yet. And we all have, if people here have built OAuth integrations, it can be, there's more pain there, there's more friction to go through, but it's necessary friction before you productionize something that's talking to MCPs. Local, you can get away with it fine, but once you go into production, you really need to be supporting OAuth. Okay, and then the final kind of lesson that we learned is your MCP is completely pointless until people can find it. You saw in the Docker example just now, going into a marketplace, finding MCPs that did what they needed and plugging them in. Without that discoverability, nobody can use your MCP server. So we need to make it easier for people to be able to find MCPs. So what we've done there is as a community, we've created an open source MCP registry. This just shipped 2 weeks ago. There's a link there. Go and have a look. You basically have now the ability to use an API to publish details about your MCP server to the world as part of an open source, everybody shares, a base repository of the MCP servers that are available. Now, I've been around, like I said, I'm old. I've been around through lots of different programming languages with package managers. I've been around with lots of different, like NPM and .NET and things like this. I've been around in different ecosystems. The thing that I'm very keen we prevent is creating a single point of failure, a single monopoly of registries, because no one registry solves everybody's problems. There's a lot of trust involved in which MCPs you switch on and you enable. And so we need to be able to make it so people can have their own MCP registries and be able to distribute that load. GitHub now have an instance of an MCP server that goes and you can get the GitHub catalog of MCPs. That adds additional data from the base catalog, such as how many stars it's got, how popular it is. So we can see Context 7's really popular. The GitHub one is obviously. Markdown, that's a cool plugin from Microsoft actually, which turns stuff into doc files and things like that into Markdown so you can crawl them. It's cool, super popular. What we want to do is build an ecosystem, just like you saw with the Docker example just now, where we have a central registry where we can make MCPs discoverable, and then you have local registries. So Docker has a registry that you can go to when you're using stuff inside the Docker area. Your company probably should have a registry at some point that allows you to decide which ones you trust in your environment and all those sorts of things. And that discoverability is kind of the key to the next level to make MCP, the success it is. MCP has now become the API layer of AI. It's one. It's how it's going to work. I don't see anything else coming along here. There are complementary things like A2A for being able to talk between agents. But in terms of tool calling, being able to do things, MCP is the protocol we're going to be using. MCP is fully open. It's available for everybody to use and talk to. So I would encourage everybody to get involved. If you want to be part of this community, now is the time to influence the direction of what we're probably all going to be relying on for the next 20 years. So if you want to go to the MCP community site and get started, that's there. And then there is also a Discord as well that you can join in terms of being involved and being part of the community steering the future of MCP. I'm just going to leave that briefly up for a second till I see the cameras go down. Great. One more second. There we go. Okay, so there was the lessons we learned very briefly. I'm around all day today if people want to talk more and chat a bit more. But what I want to do is encourage everybody to get involved in the MCP community. Let's build from here together. And now, on to questions. Thank you for your time.